Now look up, I want to show you something about this isomerism in organic structures. Now this question said, how many structural isomers of chlorobutane are possible? Remember in my video about 2 days ago, I solved the isomers of butane, right? Yes, here we say that butane have two isomers, Abi? Okay, now that one is a jam question, or this one too is a jam question. Now look at this. This one is talking about chlorobutane. Now in this solving, we will find out if chlorobutane and butane actually have different isomers in structures. Do they have different isomers? Remember, for normal butane, we found out that the isomers is 2. Remember. Then this one, let us see. They are asking us. Look at the options they give. Now, before we start, normal butane, look at this formula for normal butane. C4H10. Now, chlorobutane has C4H9Cl. Are you seeing anything? H9. So one of the hydrogen is replaced by a halogen, which is chlorine in this case. So this is a typical haloalkane. This organic family, this hydrocarbon family, we call them haloalkanes, right? Alkane that are substituted with halogens. Are you with me? Now, if this is a haloalkane, CH3, CH2, CH2, now CH2Cl. This is out 1, 2, 3, 4 carbons. Then hydrogen 2, 4, 6, 9. Then Cl. Look at it here. So this is chloroalkane. Chloroalkane. Now this is one of the isomers, chloroalkane. Now what other one can we get? We can also get another instruction if we change the position of the word of the chlorine, the halogen. So in this one it is in the first carbon, right? Now let us bring it to the second carbon. If we bring it to the second carbon, then that is why I completed this one, hydrogen 3, because I'm removing this. Then this one now that is 2, I will remove 1. The one I remove it, place it here to make it 3. Then I will now place the chlorine here, right? Now this is 1, 2, so it is in carbon 2. This is 3, this is 4. So this is 2 chlorobutane. 2 chlorobutane. Does it make sense? Yes. So this one is what? Chlorobutane. You can also say 1 chlorobutane. Your choice. This is 2 chlorobutane. So this is a second structural isomer. Is that all? Now let us find out. Remember that these are all structures of a normal butane from where chlorobutane was formed, right? Now we have an isomer of butane that is like this. This is CH3, CH2, CH3, right? And this CH3. This is 2-chloropropane, right? This is an isomer of butane. So to make it what our problem is, so this is 2-methyl, sorry, not 2-chloro, 2-methyl. Now, first of all, this chlorine, remember here I said you can choose to call this chloroalkane or 1-chloroalkane, right? Now even if you say only chloroalkane, you are not at risk because there is no other substituent here. But here now, if I want to use chloropropane here, I may be at risk, right? Because there is another substituent. So I can be careful to put the position of this chlorine. Remember, the substituent here are chlorine and methyl. Chlorine starts with C, methyl starts with M. So we'll give C the preference in alphabetical order. So this chlorine is in the first carbon, right? Because this is just like it is. This place is just acting like they are the functional group, right? Now this is 1-chloro, 2-methyl propane, right? Is an isomer of a structural isomer of chlorobutane. Then we can also have another one. If we place this one, remember we have placed this one from here now. Oh, sorry, this should be here, please, so that it can be 2. Our drawing can be 2. This is CH3, right? We are correct. Oh. Don't mind me. It's an oversight. So this is carbon 1, carbon 2, carbon 3. Right? Now, what if we also do something like this and place? What if we also do something like this and place CH3, CH, CH2, CH3. Now this chlorine, let us also place it on top of this center carbon that carries the methyl. So there will be no H again. Everything is occupied. So we have something like this now. CH3, C, CH3. Then down here I have a CH3. Up here I have a chlorine. Are you with me? So let's count. Hydrogen is 3, hydrogen is 3, hydrogen is 3. That is H9. Chlorine 1. Then C is 4. 1, 2, 3, 4. Right? We are still in order. So what do we call this? Carbon 1, 2, 3. Now this is chlorine and methyl are all on the center carbon. Now you just obey the alphabetical order. Chlorine comes first, which is C. So this is then in the center carbon, which is number 2. So this is 2 chloro, 2 methyl, 2 chloro, 2 methyl, 2 chloro, 2 methyl propane, 2 chloro, 2 methyl propane. Is that clear? Is there any other thing we can get? Now, if you move this chlorine backward, you cannot get 3 chloro, right? If it comes to here now, then here must be the first carbon. You start from the left, no longer from here, right? So you cannot get 3 chloro. There is no 3 chloro, right? Remember, chlorine is our chief point of what? Emphasis, not the methyl, right? So this is, we have exhausted the possible structural isomers of this. So we have 1 chloro 2 methyl propane 1, 2 chloro 2 methyl propane 2, chloroalkane or chlorobutane rather, to give a specific name. Chlorobutane, please. Chlorobutane, that is what? 3. Then 2 chlorobutane. You can also choose to call this 1 chloro. I said it. Then this one 2 chlorobutane. That is what? 4 structural isomers. That is what? Option D. So this is very clear. So I believe you can now be able to write out the structural isomers of organic or hydrocarbons in case they ask you another one in either WAEC or JAM that is not this. In case they leave butane entirely, maybe they did not ask you butane or chlorobutane, they move to another listing number. So you can be able to write it carefully. So thank you for watching. See you in the next video.